In this video, I'm going to take you through our first section of our new chapter 10 on volume. And no, that is not like turn up the volume on your phone or your iPod or whatever. This is the quantity of three-dimensional space enclosed by some boundary. So that means like just think of filling up this with water. How much water would fit in there? That's volume. So these are the kind of solids or shapes we're going to be looking at, 3 dimensions. So the one students often get confused with is the oblique cylinder. It's just a cylinder that's kind of turned a little bit, but it would have the same volume as if it was upright. So, and there's a lot of vocab here. A lot of it we're familiar with: radius, height, vertex. Oblique is probably the weirdest word here. So oblique just means kind of like slanted. Okay, volume of prisms and cylinders. We'll do a rectangular prism first. Probably remember this. The easiest way, if you've got these cubes in front of you, is just to count. You can see they're stacks of 3. So you can 3, 6, 9, 12, 15, 18, 21, 24. But we don't really want to, count cubes every time. There's a shortcut, of course. We can take these dimensions and you get this formula: length times width times height for the volume. So any order, 3 times 2 times 4, 4 times 2 times 3, it's all going to be 24 cubic centimeters. And we want to say cubic centimeters because it's 3 dimensions being multiplied together. Volume is always whatever our units are to the 3rd power. And area was squared. Okay, another one. Obviously, we don't want to count these. Just multiply them together. 8 times 3 times 12. And this one, 10 times 10 times 30. And make it cubic centimeters. Okay, in general, I just went past that. This says volume equals area of the base times the height. I mean, in this case, it's easy to see. The area of the base of this shape, kind of like the area of this rectangle. Whoa, that got all crazy on me. The area of this rectangle is the same as the base, and then we're multiplying by the height. We're going to use that concept for all the rest of them because, is there really a formula for this? But if we think about this right triangle and we find the area of it, okay, area of the base, because that's the same as this. 6 times 8 divided by 2 is 48 divided by 2 is 24. But then if we stack 12 of those triangles on top of each other, it's going to fill in this whole shape. So then we just take area of the base, which was the triangle, times the height. 24 times 12. Let's get our beast mode. Beast. 24 times 12 is 288. So we can say 288 cubic centimeters. Let's just say centimeters. So first find the area of the base, multiply by the height. That's it. There is a little bit of shortcut when it's a right triangular prism. If we just did 12 times 6 times 8, we would get exactly twice this much. Because that would be giving us what? A rectangular prism volume. And if we cut that exactly in half, we would get the same 288. So a little bit of a shortcut there, as long as you realize you don't need that 10 there. Okay, on to a trapezoidal prism. So this one's a little bit trickier because if you think, okay, area of the base times the height, and you think this is the base, it's not. Because that shape is not consistent throughout. If we start raising up those rectangles, it becomes too much, right? So we have to think of the trapezoid as the base. That's why I'm calling this a trapezoidal prism. Well, I'm not calling it, it's just what it's called. So this is the area that's the shape that is consistent throughout. And if we stack up 10 of them going this way, we would create that shape. So we want to find the area of that trapezoid, B1 plus B2 times height divided by 2, back from our area chapter. So B1, let's say, is 8. So that's B1 plus B2, which is what? The same as this. So 8 plus 4 divided by 2. And the height is 5. This vertical, that would be the same as this or this. or any of those. So thanks for giving us this, because that'd be hard to find. 8 plus 4 is 12, times 5 is 60, divided by 2 is 30. So that's for just the area of the base. That goes there. And then the height is 10. So if you think of this, like tip it over so that this trapezoid is on the bottom, then the height would be 10. So then that's 300. Let's just say cubic centimeters again. Okay, got one more shape, cylinder. Area of the base times height. So this circle is the base, pi r squared, back from our area chapter, times the height, which is 15, we can see right there. And the radius is 8, so that's 64 pi times 15. So let's get out beast mode. 64 times 15, I'll just do that first. 960, so in case someday you might have a math teacher asks you for in terms of pi or exact. Remember we talked about that, exact value. This symbol encompasses an infinitude of decimals. So then if I ask you for like real life answers, 960 times pi, or we could have just done it like this, 64 pi times 15 all in one go, same thing. Let's round that to the nearest whole number, because the 0.9, that's close enough to 3016. Okay, that's it for this section. Thanks for watching. Goodbye.